Hello! In this video, check this out. Let A be any object. Then there exists a set, which we call a singleton set of A, which satisfies the following statement. For all objects Z, Z is an element of our singleton set, if and only if Z is equal to A. Now, all this definition tells us is that given an object, say A, well, there exists a set which satisfies this statement. What we're going to prove is that there's only one set which satisfies this statement, right? We're going to prove that the singleton set is unique. Okay, so now let's get into proving that idea. And since we're trying to prove a statement about every object, give me an arbitrary object. I'll call it A. Now, from our definition, every object has a singleton set. So, our object A has a singleton set. But remember, our goal is to show that A has only one singleton set, right? And to prove uniqueness, what we can do is we can suppose that A has two singleton sets. I'll call them X and Y. And to prove uniqueness, all we got to do is prove that X is equal to Y. Now, since X is a singleton set of A, what that means is, by definition, is that for all objects Z, Z is an element of X, if and only if Z is equal to A. Also, since Y is a singleton set of A, this means that for all Z, Z is an element of Y, if and only if Z is equal to A. Now, to prove that X is equal to Y, what we're really trying to prove is, for all objects Z, Z is an element of X, if and only if Z is an element of Y. Right? Because that's what it means for two sets to be equal. And since we're trying to prove a statement about all objects, give me an arbitrary object. I'll call it Z. Right? And with this object Z, we want to prove that Z is an element of X, if and only if Z is an element of Y. And we're going to prove that through a chain of if and only ifs. And to see how that comes together, check this out. Now, we know that for all objects Z, Z is an element of X, if and only if Z is equal to A. So since this statement works for all objects, it must work for the object Z that we have here. So we can take this Z, substitute it for the Z we have here, and we have that Z is an element of X, if and only if Z is equal to A. And similarly, we know that this statement right here works for all objects. So it must work for the object Z that we have right here. So Z is an element of Y, if and only if Z is equal to A. So, putting this together, we have an arbitrary object Z, and from there we prove Z is an element of X, if and only if Z is an element of Y. Since Z was arbitrary, this means for all objects Z, Z is an element of X, if and only if Z is an element of Y. And that means we have proven the sets X and Y are equal. So now let's put this all together. We gave ourselves an arbitrary object A, and we said, oh yeah, A has a singleton set. How do we know A has exactly one singleton set though? Well, we gave ourselves two arbitrary singleton sets of A, X and Y, and we showed that they have to be equal. So that proves that this singleton set is unique. And so yeah, this completes the proof. And yeah, that's pretty much it for this video.